All right, welcome to the Explainer. Today, we're going to build a really solid mental model for one of the most common viruses you will ever see in your career, the Epstein-Barr virus, or EBV.
Let's just start with this number because it really tells you everything you need to know about the EBV story. Up to 95% of adults around the world are seropositive. That means they have this virus hanging out in their system, usually without any symptoms, for their entire lives.
So, what does this super common virus actually do? Well, I can tell you, it's a whole lot more than just the kissing disease. So let's get into the biography of this absolute master manipulator.
Okay, we'll kick things off with Act 1, that very first time a person gets infected with EBV. And what's wild is that the clinical picture, it totally depends on how old the patient is.
And this is where it gets really interesting. You see this huge difference based on age. In little kids, EBV is super stealthy. A lot of the time, they have no symptoms at all. But you get to adolescents and young adults, and bam, you get that classic infectious mononucleosis, or mono, that we all studied. The fever, the sore throat, the swollen lymph nodes.
Okay, high-yield Pearl time, especially for your boards. That common monospot test? Forget about it in young kids. It's just notoriously unreliable. You've got to order the EBV-specific antibodies to actually nail the diagnosis in that age group.
So this right here, latency, this is the whole point of the EBV story. After that initial infection is over, the virus doesn't just pack its bags and leave. Nope, it becomes this quiet, lifelong roommate, just hiding out in your body's B cells.
And that brings us to Act 2. Let's see what happens when this silent roommate starts causing serious trouble, sometimes years or even decades down the road.
So what happens when the immune system gets distracted? Maybe because of another illness or immunosuppressant drugs? Well, that's when this latent virus can wake up and be linked to a whole range of really surprising, delayed complications.
And check this out. This quote really drives home just how big of an impact that latent infection can have. A landmark study of over 10 million people found this staggering association. We're talking a 32-fold higher risk of developing MS after an EBV infection. This basically put EBV at the top of the suspect list for what kicks off MS.
Now this, oral hairy leukoplakia, you are definitely going to see this on the wards, especially in your patients with HIV or in transplant recipients. And here's the key differentiator from something like thrush. You can't scrape these plaques off. It's a huge, visible red flag that the immune system is losing control of that latent EBV.
But the story takes a much darker turn. And that brings us to Act 3, where EBV shows its most dangerous side. Its role as a Class 1 carcinogen. Just look at the variety of cancers EBV is tied to. It's incredible. We're talking B-cell lymphomas like Burkitt and Hodgkin. We're talking carcinomas in the nasopharynx and stomach, even PTLD, post-transplant lymphoproliferative disorder. And each one has its own fascinating backstory, like how malaria in Africa acts as a cofactor with EBV to cause Burkitt lymphoma.
So that's the big question for us, right? How in the world does a virus actually help cause cancer? What is the mechanism here? How does it turn a healthy cell into a malignant one?
And here it is. This is the molecular smoking gun. Researchers have figured out that a specific viral protein, EBNA1, which, by the way, shows up in all EBV-related cancers, can literally attach to our own DNA and break it. That creates genomic instability, which is a major critical step on the road to cancer.
All right, let's bring all this back to the bedside. Time for our final act, the practical, need-to-know pearls for managing your patients with EBV-related disease.
First things first, for someone with acute mono, your job is pretty straightforward. It's all about supportive care, pain relievers, fluids, rest. But honestly, the most important thing you can do is counsel them about the risks, especially splenic rupture, and telling them no contact sports.
Okay, but it's a virus, right? So this is a question you're going to get all the time from patients, maybe even from colleagues. Why don't we just hit it with an antiviral like acyclovir? And the answer is absolutely key to really understanding EBV.
And here's the bottom line. Antivirals can stop the virus when it's actively replicating, that's the lytic phase, but they have zero effect on the latent virus that's hiding out in the B cells. And since that hidden latent virus is what causes all the major long-term problems, the cancers, the autoimmune links, the antivirals just don't offer much clinical benefit.
So where does that leave us? Well, for now, with no way to get rid of the latent virus and no vaccine, our focus is really on managing the fallout. We're monitoring our high-risk patients, like transplant recipients for PTLD, and treating the various complications as they pop up.
So, to wrap all this up, Let's look to the future with a thought that is really going to define the next chapter of the EBV story. This is the huge question for researchers and for public health. When we finally get a vaccine, what should its goal be? Should it just stop people from getting mono? Or should it be designed to control that lifelong latent reservoir to prevent things like cancer and MS? Answering that is going to be the key to finally taming this ubiquitous, lifelong tenant.